Hey, I'm Niall, and this is Lloyd, who you might notice has had a couple of upgrades. In my last video, I sort of focused on the work that I needed to do to get him up and running initially, but in this video, I'm instead going to focus on some of the limitations of that setup, some of the upgrades I've been implementing, and why those upgrades are important for our particular use cases. It's a lot to cover, so just to jump right back into things. In my last video, I said that Lloyd is controlled by 6 pretty standard stepper motors, and that made it really easy to get him up and running with a CNC stepper driver like this, but it did introduce its own set of problems. So if you're not already familiar, like the name implies, stepper motors are just motors which can only move in discrete steps. And while that's great for positional tracking, it usually doesn't cause any issues. When you want to run at particularly low speeds, the constant starting and stopping between steps can cause vibrations in the motor, which get amplified through the machine, thus a loss of accuracy on the tool line. There are things like micro-stepping which could help to circumvent this issue, but due to the lower top speeds and other integration issues I need to solve in order to use these motors, I'll instead be replacing them with these ClearPath fully integrated servo motors. These motors can move slower and faster than your traditional stepper, while also providing better torque across that entire wide range of speeds. And since they're also closed loop, there's no risk of them losing their position over time. But of course, for all the issues that these things solve, they also introduce a new one. These new motors are neither the same shape or the same size as any of Lloyd's original motors, so thus begins the process of building out adapters so we can actually use these things. I start off by prototyping my design in Fusion 360 with 3D models from the manufacturer and measurements from the parts that I have on hand. Once I'm pretty comfortable with that design, I can head over to our 3D printer room and get some prototypes made. These prototypes not only allow me to double check my measurements, but they also allow me to put together the entire assembly so that I can be sure everything fits together and can move around with appropriate clearances. Once I've looped on this process a couple of times and I'm really comfortable with my designs, I can move over to our normal printer room to print out technical drawings which describe all of their critical dimensions. I can then hand these off to Jim.
Oh, thank you very much.
And he can manufacture them in our metal shop without having me around. With the end result of that process looking something like this, a set of full metal adapters which allow us to install our new motors without modifying any of the original assembly. So now that I'm over that hurdle, it's on to the next. Even though these motors do have a step and direction interface, if I want to get the most out of them, I'm going to need to use the communication hub and C++ library that they came with. It'll give me access to internal metrics like torque on the shaft or position of the encoder, and most importantly, it'll allow me to say, even as the robot is powered off, if something moves or say I need to come in and change a tool, it'll still keep track of the position of that shaft, and once I turn my robot software back on, it'll be aware of any changes that have happened, and I can accurately home to a new position. This is mostly software development that's taking place off-screen, but I did want to touch on it specifically because I've been chunking out a lot of my code into a library to make development easier. It's nothing crazy, but it does allow me to go in and declare my robot as a multi-axis machine with this many axes, override a couple of critical functions, and now I can safely script and move around my robot without being dependent on ROS. Plus, the ability to set target speed and accelerations should allow you to still execute joint space trajectories that ROS generates without having to be in contact with it in real time. So if you happen to have a project where something like this might be useful, I've linked to the GitHub repo down in the description.
So big picture, we've got the new hardware, we've got the new motors, and we've got the new software. But even after all of that, Lloyd is still pretty much useless, and that's primarily because we've been using ROS to control him. Now, while ROS is a very powerful development platform, at the end of the day, it is still a development platform which requires specific programming experience to use in a meaningful way. So that not only makes it impractical for us to use it as our main means of communication, but also it leaves a lot of opportunities open for someone to make a mistake. And on a robot this size, mistakes can go from dumb to dangerous really quickly.
So in order to add another layer of abstraction, I'm going to be using this software called RoboDK. And RoboDK is just an example of offline robot programming software where I tell it how my robot is shaped and how it moves, and it figures out whether or not a program can actually be executed on my robot. It also makes it a lot easier to attach new tools to the robot when in ROS I'd have to go in and create a custom path planning package. In this one I can just download a tool file, import it into my job, and all the path planning is done with respect to that. So that, in combination with its ability to work with G-code from something like FeatureCam,
should make for a pretty powerful robot workstation. And as much as I'd love for this to be the part of the video where I show you the robot painting or carving out a sculpture, the reality is life's busy, our metal shop is still coming into its own, and I'd really like to wait until I can get some good experience with TIG welding before trying to build out the second round of parts. But if that does sound like something that's particularly interesting to you, you can stick around to the next video, and within the next few weeks or so, we should be using that 3D printed router mount you may have seen earlier in the video to carve out some foam sculptures and really push what we can do with this new software. Otherwise, thanks for making it this far, and I hope you liked the video.